Use a double integral to find the area bounded by y equals the natural log of x, y equals 2 times the natural log of x, and x equals e in the first quadrant. All right, so let's proceed by sketching the region of integration, which will always be our first step. All right, so the natural log of x. If I plugged in an e, which is about 2.718, I'd get out 1. So just scale something like this. 2 times the natural log of natural log of x. I get that same spot. This gets multiplied by 2. Just a nice stretch vertically, something like this. And then x equals e, a nice vertical line going through those 2 points I sketched. So we're trying to find this region's area. All right, so here's my double integral. There's my region R. And we're going to use Fubini's theorem, which first means we need to pick an order of integration. Well, if I was to try to integrate with respect to x first, I would need 2 separate integrals, right? Because I see that I would have red, purple from left to right, and then when I get to this point, I'd have 2 times the natural log of x in red, and then the vertical line in blue. So let's integrate with respect to y first and see if that works. So I draw a ray in increasing direction of the first variable. I hit natural log of x, and then 2 times the natural log of x. And now I need bounds for x that include the whole region. Well, nicely enough, the x-intercept in the vertical line gives me those bounds, 1 and e. When I'm doing one of these double integrals, I always enjoy the fact that after the first round of integration, I simply have a calc 2 problem. So I have y evaluated from y equals the natural log of x to 2 times the natural log of x, and I'll end up taking a derivative with respect to x. And then finally, let's see, 2 times the natural log of x minus the natural log of x is the natural log of x. So I need an antiderivative of the natural log of x. Pause the video here and see if you can either remember what that antiderivative is, or find it. Okay, well, if you know this antiderivative, that's great. If you don't, it's a little integration by parts problem. So I could pick u and dv nicely, and then v becomes x, and then the derivative of u here is 1 over x dx. All right, so I'd have u times v, x times the natural log of x. I need to evaluate that from 1 to minus e. I should write that down. 1 to e minus, and then v du, well, x times 1 over x, that's nice. That's just a dx from 1 to e. And I'm just going to go on and simplify this here so I don't have to get another board out, because it's just an x evaluate also from 1 to e. So if you remembered the antiderivative, it's x times the natural log of x minus x, evaluated from 1 to e. And now I need another board anyway to do the evaluation. So I have to plug in an e. So I have e times 1 minus e. Well, that's going to be easy to evaluate. Minus 1 times the natural log of 1, well, that's going to be easy to evaluate, minus 1. So that's 0. Minus 0 minus 1, we just get 1.